Your dashboard is lying to you right now. Not because your car is broken, because your car is corroding. Right now, somewhere on your vehicle frame, a ground connection is failing. A microscopic layer of oxidation is building electrical resistance into your chassis. And that resistance is generating phantom voltage signals across your entire electrical system. Your ECM is receiving corrupted data from sensors that are perfectly functional. It responds by throwing fault codes for components that have nothing wrong with them. You walk into a shop with 5 different warning lights illuminated simultaneously. The scanner shows codes for the transmission, the AB system, the oxygen sensors, and the throttle body. The service advisor presents a repair estimate approaching $1,500. They recommend replacing the ECU, the throttle position sensor, and the transmission control module. Every single one of those components is working perfectly. The entire electrical cascade originated from a ground connection the size of a postage stamp. A $1 box of baking soda and a $1 tube of dielectric grease solves this completely. No ATU replacement required, no sensor swaps necessary, no wiring harness replacements authorized. These 2 compounds neutralize corrosion chemistry and permanently seal electrical connections from oxygen. This is the diagnostic truth they deleted from every shop training manual. The automotive electrical diagnostic industry is built on deliberate complexity. Modern vehicles contain between 50 and 150 individual electronic control modules. These modules communicate across multiple data networks simultaneously. Every single one of them depends on clean, stable chassis ground connections to function correctly. A ground connection is where electrical current completes its circuit back to the battery. Without a clean low-resistance ground path, voltage readings across the entire system become unstable. Sensors report incorrect values because their reference voltage is contaminated by resistance. Control modules misinterpret these corrupted signals and generate fault codes in response. The entire electrical system behaves as though multiple components have failed simultaneously. Mechanics connect a scanner, read the codes, and recommend replacing the components those codes reference. They never check ground resistance first. Checking ground resistance takes 5 minutes with a cheap multimeter. Recommending component replacements generates $400 to $1,500 in parts and labor revenue. The financial incentive to skip the ground check is enormous and deliberate. Shops know that corroded grounds cause phantom codes on every vehicle over 5 years old. They know because they see it constantly. They choose the profitable diagnostic path every single time. A corroded ground connection requires $2 of chemistry to fix permanently. A misdiagnosed ECU replacement costs $800 before programming fees are added. They built $1 billion misdiagnosis empire on a $2 chemistry problem. Today, we permanently bankrupt their phantom code diagnostic machine. The electrochemistry of ground connection corrosion is completely documented science. It has been studied extensively in military electronics, marine engineering, and aerospace applications. All of these industries discovered the same fundamental truth decades ago. Dissimilar metals in contact with each other and with moisture create galvanic cells. A galvanic cell is essentially a miniature battery generating its own voltage. Your vehicle chassis ground connections are almost universally steel bolt to copper wire terminal. Steel and copper are dissimilar metals with different electrochemical potentials. When moisture bridges these 2 metals, galvanic corrosion begins immediately. The steel oxidizes preferentially because it is electrochemically less noble than the copper. Iron oxide forms at the contact interface between the bolt and the terminal. Iron oxide is not a conductor of electricity. It is an insulator. As the oxide layer thickens, the electrical resistance at the connection increases proportionally. This added resistance creates a voltage drop across the ground connection. This voltage drop contaminates the reference voltage that every sensor on that circuit uses. A sensor designed to operate on a clean 5-volt reference now operates on 4.7 volts. Its output signal shifts by the same proportion. The ECM receives a signal that looks like the sensor is reading incorrectly. It logs a fault code for that sensor and illuminates the warning light. Now multiply this across every ground connection on the vehicle simultaneously. Vehicles have between 15 and 40 individual chassis ground points distributed across the body. Engine grounds, transmission grounds, body grounds, and instrument cluster grounds all corrode independently. Each corroded ground introduces its own resistance and its own phantom voltage contamination. The result is an electrical system that appears to be catastrophically failing across multiple systems. In reality, every component is perfectly functional. Only the reference voltage infrastructure has been compromised by basic electrochemical corrosion. Baking soda neutralizes the acidic corrosion byproducts at the connection surface. Dielectric grease then seals the cleaned metal surface completely from atmospheric oxygen. Without oxygen, the electrochemical corrosion reaction cannot proceed. The ground connection remains clean, low resistance, and stable permanently. Every sensor on that circuit immediately begins reporting accurate data again. The phantom fault codes disappear from the ECM memory on the next drive cycle. Your warning lights extinguish permanently without replacing a single component. This channel exists to replace expensive guesswork with cheap, accurate electrochemistry. Subscribe right now because this series gets more financially dangerous to dealerships every week. Next week, we expose the oxygen sensor, cleaning cartel completely. We reveal the Wu-Mei-Yuan propane torch that burns carbon fouling off sensors in minutes. Following that, we expose the sunroof drain flood disaster and the $2 fix that prevents it. Share this video with every driver currently paying for electrical diagnostics right now. Hit the like button and push this truth through the algorithm. Stay right here because the exact ground restoration protocol begins immediately. You must understand exactly how a corroded ground destroys an entire electrical system. Start at the battery in your engine bay. Your battery has two terminals, positive and negative. The positive terminal connects through fuses to every electrical component on the vehicle. The negative terminal connects directly to the engine block and the vehicle chassis through heavy ground cables. Every electrical component on your vehicle completes its circuit through the chassis metal. The chassis itself is the return wire for the entire electrical system. This means the electrical quality of every sensor and module depends on chassis conductivity. When you install a sensor in the engine bay, its ground wire bolts to a nearby chassis point. That bolt passes through painted metal to reach bare steel beneath. Over time, moisture wicks under the bolt head through capillary action. Road salt accelerates the electrochemical reaction dramatically in winter driving regions. The iron oxide layer grows thicker with every seasonal moisture cycle. A fresh ground connection measures near 0 ohms of resistance. A moderately corroded ground connection measures 0.3 to 0.5 ohms. This sounds insignificant until you calculate the voltage drop it creates. At 0.5 ohms with typical sensor current flow, you get a measurable voltage drop at the sensor reference. That voltage drop shifts every sensor reading on that ground circuit proportionally. The MAF sensor reports lower airflow than actual. The throttle position sensor reports incorrect pedal position. The coolant temperature sensor reports wrong engine temperature. The ABS wheel speed sensors report phantom speed differentials. All of these false readings generate fault codes simultaneously. The scanner shows a vehicle that appears to be comprehensively failing. The shop recommends replacing every component that generated a code. The actual fault is a $2 chemistry problem hiding under a bolt head. This is the most profitable misdiagnosis pattern in the entire automotive service industry. It affects every vehicle over 5 years old, without exception. Vehicles in coastal regions corrode faster due to salt air humidity. Vehicles in northern states corrode faster due to road salt applications. Vehicles parked outdoors corrode faster than garaged vehicles. The only vehicles that escape this problem are those whose owners know to prevent it. Now you are one of those owners. The two-compound solution works through complementary chemistry. Baking soda is sodium bicarbonate, a mild alkaline compound. Corrosion products on steel and copper are acidic in nature. Sodium bicarbonate reacts with acidic corrosion compounds through a simple neutralization reaction. The acid and base react to form water, carbon dioxide, and neutral salt compounds. The corrosion products foam and dissolve on contact with the baking soda solution. This physically removes the insulating oxide layer from the metal contact surfaces. The metal beneath is exposed, clean, and electrically conductive again. Dielectric grease is a non-conductive synthetic silicone compound. It does not conduct electricity itself. Its function is purely physical and chemical barrier formation. When applied to a cleaned metal surface, it physically excludes atmospheric oxygen completely. Without oxygen present at the metal surface, the oxidation electrochemical reaction cannot initiate. The metal surface remains bright, clean, and low resistance indefinitely. Dielectric grease is also completely chemically inert to all metals and rubbers it contacts. It does not degrade, wash away, or break down under sustained heat and vibration. One application creates permanent protection for the life of the vehicle. Together, these two compounds cost exactly $2 at any hardware or grocery store. Together, they permanently eliminate the most profitable misdiagnosis pattern in automotive service history. The financial mathematics here are staggering. A misdiagnosed ECU replacement costs exactly $800 plus $200 programming fee. A misdiagnosed throttle body replacement costs exactly $400 plus $100 labor. A misdiagnosed ABS module replacement costs exactly $600 plus $150 labor. A shop that misses a corroded ground can generate $2,000 in unnecessary repairs from one visit. This happens in shops across the country every single day. Over a vehicle lifetime, drivers with chronic ground corrosion issues can spend $5,000 chasing phantom codes. Now look at the factual cost of the electrochemical solution. A box of pure baking soda costs exactly $1. A tube of dielectric grease costs exactly $1. A basic OBD2 code scanner to verify the codes clear costs $25 once and lasts forever. Total investment for permanent ground restoration is $2 plus a one-time $25 scanner purchase. The misdiagnosis industry cannot fund corporate infrastructure on a $2 fix. They require your electrical ignorance to maintain their diagnostic revenue. Your phantom fault codes are a recurring billing event they rely on completely. Here's the exact ground restoration protocol for your vehicle. Gather your materials before beginning. You need baking soda, clean water, an old toothbrush, dielectric grease, a wrench set, and sandpaper. Safety glasses and gloves are mandatory throughout this procedure. Step 1. Purchase a basic OB2 scanner from any auto parts store for $25. Plug it into the diagnostic port under your dashboard and photograph every active fault code. Write down the exact code numbers before clearing anything. This gives you a baseline to verify the repair worked completely. Step 2. Locate your vehicle ground connection map using a free online service manual. Every vehicle manufacturer publishes ground locations in their service documentation. Search your specific year, make, and model followed by the words ground location diagram. Priority ground points to inspect include the engine to chassis ground cable connection, the engine to body ground strap, the battery negative cable chassis connection, the instrument cluster ground behind the dashboard, and any body ground bolts in the trunk or door pillars. Step 3. Begin with the engine to chassis ground cable, as it affects the most systems simultaneously. Use the correct wrench size to remove the ground bolt completely. Inspect the contact surface on both the chassis metal and the cable terminal. White, green, or brown powder indicates active galvanic corrosion. Step 4. Mix 1 tablespoon of baking soda into 1 cup of clean water. Apply this solution to the corroded surfaces using the old toothbrush. Scrub the contact surfaces firmly until all visible corrosion foam and dissolves away. Rinse the surfaces with clean water and dry completely with a clean rag. Step 5. Use fine 220 grit sandpaper to lightly abrade the contact surfaces. You are exposing fresh bare metal beneath any remaining oxidation layer. The surface should appear bright and metallic after light sanding. Step 6. Apply a generous coat of dielectric grease to both contact surfaces immediately. Do not allow the freshly cleaned surfaces to sit exposed in air for more than 2 minutes. Oxygen begins recontaminating bare metal almost immediately in humid conditions. Step 7. Reinstall the ground bolt and tighten it firmly to its factory torque specification. Excess grease will squeeze out from under the terminal as you tighten. This is correct and confirms full contact surface coverage beneath the terminal. Step 8. Repeat this exact process at every ground connection point on the vehicle. Work systematically from engine bay grounds to body grounds to trunk grounds. The complete procedure on a typical vehicle takes approximately 90 minutes. Step 9. After completing all ground connections, plug in your OBD2 scanner. Clear all stored fault codes from the ECM memory completely. Step 10. Start the vehicle and allow it to idle for 5 full minutes. Drive the vehicle for 15 minutes, including several stops and moderate acceleration events. Reconnect the scanner and check for any returning fault codes. If the grounds were the source of the phantom codes, the scanner will show 0 active faults. Warning lights that were illuminated before will have extinguished permanently. If any codes return, they represent genuine component faults worth investigating further. You now have clean electrical data and can make accurate repair decisions. You just restored the entire electrical foundation of your vehicle for exactly $2. This is a direct assault on the most profitable misdiagnosis pattern in automotive service history. Military electronics engineers have known about galvanic corrosion prevention for decades. Marine engineers coat every electrical connection with dielectric compound as standard practice. Aerospace technicians treat ground connections as safety, critical maintenance items. The automotive service industry treats corroded grounds as an invisible revenue source instead. Their phantom code diagnostic empire collapses against $2 of basic electrochemistry. Share this with every driver who has ever paid for electrical repairs that did not fix the problem. Share it with every person sitting in a shop right now facing a 4-figure electrical estimate. Every view pulls another dollar from the misdiagnosis machine permanently. Every subscription keeps this electrochemical knowledge free and accessible to everyone. In the next video, we completely expose the oxygen sensor replacement cartel. We reveal the WME propane torch that burns carbon fouling off, sensors, in under 10 minutes. We show you exactly how a perfectly functional sensor gets condemned by a layer of carbon dust. Stay disciplined, stay grounded, and never let a shop replace components before checking ground resistance first.